Okay, well, good morning, folks. Thank you for attending the ARC Forum. This is we're almost through the hump, as they say. This is our last session this morning, and we do appreciate your sticking with us, and I hope you get some interesting and informative information, and we'll hopefully address some interesting topics during the panel discussion once we have all the speakers go through. My name is Tim Shea. I'm a senior analyst at ARC, and in addition to focusing on the upstream, midstream oil and gas segment and a few other things like compressor monitor and monitoring and control turbines and things like that, I also look at drones and robotics. So this kind of session will mainly focus on drones, that are empowering automation, inspections, and a growing focus on sustainability. And so I'll start off with a quick housekeeping. They just ask that you silence your devices. There's an ARC app which you can provide feedback both on this session and the forum overall. So we appreciate your, certainly welcome any and all feedback you have. And you can check the ARC app. It's kind of late in the day, but you could have checked your ARC app for all the different agenda items and networking events and things like that. And then obviously most importantly, prepare and get a chance to ask your questions during the panel discussion, and probably with we hope to plan about a half an hour for that. So this is kind of some high level research we've been doing over the last year or two. We've got ARC's been covering the traditional fixed robot market for decades now, and we also have a growing team and supply chain looking at autonomous mobile robots used in, say, a warehouse and things like that. But my focus has been on drones used primarily for the process industry, so oil and gas, chemicals, electric power generation, electric power T&D, and things like that. We're finishing up hopefully a study at the end of this February on drone inspection services. We've also done some robotics, and when I mean robotics, I'm talking about, if you've seen the Boston Dynamics quadrupedal robot, there's some wheeled or tracked type devices that different companies have, and then I think we'll see probably a growing influence of bipedal robots at some point in the coming years. And there's a few other form factors like snake-like or crawlers and things like that. So there's different form factors, if you will, that people use for various applications in the robotic space. Since the focus here is obviously on drones, these are some examples of the different types of drones. You got the predominant share of the market based on our research is the multi-rotor type drone you can see on the left. Then you've got your sort of fixed wing one on the right, and then a growing area of interest I think is going to play an increasing role in the future is these drone-in-the-box solutions that were operated by autonomous. Basically, you see the enclosure. It's usually weather-proof, and it has a charging setup inside. It's also got some communications capabilities. The thing opens up. The drone basically flies on its own, a pre-programmed mission or something, then returns back down, and then most of them can self-charge and then get prepared for the next mission. So I think that's going to be an area that we'll see a real growth area, because I think with the advancements in autonomous technologies that may be used for a vehicle or whatnot, I think we're going to see a lot of activity. And you're taking the drone, it's really becoming a mobile inspection platform. Same thing with the robotic, because you're adding in intelligence analytics, whether that be edge or cloud computing or both. That's where I think the future is going to be. It's going to be where the drone, in many cases, will be perhaps as an advisor, but we have the great crew change going on in the various process industries. So I think these will be, if companies are challenged to find personnel, these technologies will be able to replace them. But the number one driver, as I mentioned up above, is safety. So that's not having someone go into a nuclear power plant or electrified substation area, or climbing a 300-foot flare stack or something like that. So those are the type of applications where we see this remote locations, emergency response for electric power providers and things like that. So that's and obviously I think COVID, as we all know, kind of accelerated this whole push towards remote operations, and increasingly a lot of companies are looking at autonomous operations, and I think obviously drones and robotics will play a role. Applications, as I mentioned, it's the kind of the hard to reach or dangerous type applications are what's the initial drivers of people investing in drones and also robotics. But some of the major applications you'll see are inspections. It could be thermal, on a utility line or something like that. It could be surveying, mapping, inspections of, going around perhaps a refinery or an offshore platform or something like that, doing various inspections and things like that. Those are some of the key applications that we're going to see. Stockpile measurement and mining and things like that. And obviously, using these tools to to develop things like digital twins. I think you can go out and use these drones to create a digital twin of an offshore platform or whatever the case may be. And so I think that's going to be an area where we're going to see a lot of interest and demand for that type of technologies. And I think as the adoption increases through the let's just say that the two major major hindrances of greater adoption are battery technology for the primarily and regulatory aspects that FAA and other countries have their own respective sort of avionic regulatory aspects. And that's something that's we're seeing some progress with the FAA. They kind of move slower than obviously most people would like, but they're moving towards the companies trying to push for type certifications. If you're familiar with the drone situation, you got a visual line of sight, which you have to always be in contact visually with the drone. You may have to have spotters and either on the ground or in planes and things like that, or beyond visual line of sight, where you can sort of fly obviously beyond the visual line of sight, but you can only fly at certain altitudes. In many cases, you have to have an observer or things like that. So those are, and again, those BVLOS waivers that you apply for, say if if the FAA receives 100, my understanding is they've approved less than 4%. And most of those are utilities that are used for emergency response. And I think BP was an early adopter. They got approval to use these on the North Slope. Of course, there's no one there but moose and bears and things like that. So there's not a real threat of these things crashing into human beings. So, which obviously is that's one of the concerns the FAA has, and the various regulations, flying at night, flying over people. So they're working together with the suppliers to advance these regulations. And as that happens, I think you'll see a greater adoption in the U.S. and obviously other countries across the world. One of the things I found that's a real plus of drones, and I guess you could say robotics, is the ability to sort of do an automated inspection. Because let's face it, if you're asking a technician to go around a plant and read dials and do all these maintenance tours and things like that, sometimes there's a human tendency to cut corners or whatever the case may be. There's not a reliable assurance of the same quality. You get different inspectors have different levels of quality and diligence. So the ability to have these drones and robots to go around and consistently do the same program route over and over again, you got to get good data quality, good data consistency. And then with the if you add in the ability for analytics and things like that, you start to get the ability to do more automated reporting and things like that. So it opens up a lot of potential opportunities. I talked a little bit about the BVLOS waivers. That's obviously, if you're only getting 4% of those, it's kind of makes it a little bit harder to get these a lot of these missions flown. But and I talked about the battery life, but I think that there's some things that are happening in that area that hopefully will have a positive impact. Obviously, when we did our research, we tend to be a little bit more conservative. I've seen a lot of these different studies about the drone market is so big and it's growing so fast. And I start talking to these guys, and they say, well, where are all these drones? Because I know there's only so many refineries across the world, and there's so many, and then you find out that a lot of these numbers are highly inflated. And so when you get down to it, my belief is that there is a drone market out there today. It's a lot smaller than people think, but I think that there's room for opportunity. And I think that that's going to be a reflection primarily of less restrictive, requirements from FAA and other organizations like that to kind of open up that envelope to allow greater mission capabilities. And I think that just the trend towards, you have this great crew change. You got a lot of folks that have a lot of gray heads with a lot of domain experience that are retiring. The challenge of trying to recruit that with the younger generation, and so I think that these drones can help fill that gap that companies may have in that area. So I think I expect to see them, becoming sort of initially a mobile inspection tool that'll, in many cases help advise some of the employees, but at some point down the road they may help actually fill in and mitigate the need to have a whole crew of people. Maybe instead of sending a crew of 5, you can only send 1 or 2, and then you have the drone do most of the heavy lifting in terms of the data collection and things like that. And so I think that'll help fill that challenge and resource allocation. And I talk a little bit about robots because I do think there's kind of a little bit of a synergy in many cases. In fact, AeroVironment, which was a sort of a military-focused company that did drones and things like that, they recently, well, last year, I think it was, they acquired a company called Telerobotics in Europe, and that company was focused on, these sort of tracked robots that had a little aperture, an arm or something like that. They'd be used for doing, ID inspection, law enforcement type applications, but there's some industrial applications that they can serve as well. So I think that they saw that the fact that, you have the drone for sort of a broader aerial perspective, then you have the robot to go in and do, some of the more tactical stuff when you have to get up close and dirty, and in some cases a drone may not be able to handle that application. So that's a potentiality that I think will happen. Obviously, we talked about that, the key of inspections and leak detection, I think, will be a pretty sizable application, more for the fixed wing type drones, because they can fly longer distances and things like that. And I think surveying and mapping and creating digital twins and things like that, there's certainly some applications there. I think in terms of the robots, like for example, Boston Dynamics was now sort of incorporating a movable arm. So they were showing videos of the robot kind of being able to open, theoretically turn a door handle and things like that. And I think as that technology on the actuator side improves, I think you'll start to see more applications opening up. And a lot of these like companies, they kind of want to open up their drone APIs because they want people to develop various applications and technologies and different types of sensors that they can incorporate, edge computing. So there's a lot of things going on, and I think that they're trying to view their robot as really kind of a mobile inspection platform. And they're trying to, encourage the development of an ecosystem, which I think, as we've all talked about during this, conference in digital technologies, you need an ecosystem because not one company can solve everything. It's just not possible. And again, as these robots are tested on offshore platforms in various parts of the world or other applications, and those are proven out, then the companies, I would imagine, they'd probably look for additional areas or applications which these drones and robots could be deployed. Okay, so this a little bit just some of the I talked about Boston Dynamics. That there's a couple of companies that have a similar quadrupedal type of look. There's Anybotics out of Switzerland. There's Unitree in China. There's a company called Ghost Robotics, which is actually being sued by Boston Dynamics right now for possible technology infringements. There's some of these wheeled or track type devices. There's actually a company called, I think it's SMP Robotics, that have like sort of the four wheels. They kind of fly around. They do a lot of physical perimeter security types applications or leak detection, things like that. So those are various types of applications. And I haven't shown the ones that they'll crawl inside a pipe or they'll crawl on the side of a tank or something like that. Those are other applications that can be had for these devices. And a lot of the same drivers are found with robotics as drones. It's really safety is the number one driver. Again, you get into the ability to do the sort of routine, over and over going routine inspections and things like that, so you get good data consistency, data quality. I think that the autonomous aspect, it's interesting when you talk to the robot guys will say, oh, our robot's autonomous. It's really a guy, 10 feet away, with a joystick, directing the robot. And so what they've been working with some of the drone guys who take the technology from the vehicle side, and it's much more autonomous when they have the various types of, detect and avoid types of technologies and things like that, where the robot actually can really be more autonomous in a sense, like we're seeing in drones. So that technology sharing, I think, is going to go a long way to helping to generate adoption. Some of these, you're looking at Boston Dynamics. If you're not even without any payload, you're talking enterprise version is at least $150,000. If you start throwing in sensors on top of that, you're talking $250,000. And a lot of companies, unless it's really a critical safety requirement for like a nuclear power plant or a highly electrified area in a substation or something like that, they're less hesitant to just have the robot go around at that price point and do the dials and inspections. And so I think they're all working to try to drive the price down, which will certainly help with adoption. Obviously, like drones, these robots, they can operate for about 2 hours plus or minus, and they have to come back to the base and recharge themselves. So that's obviously a technology sort of inhibitor in a way. I think we'll see more commercialization. Again, we're talking about the ecosystem, and as that continues to develop and they add new functionality, I think that's going to help generate more demand. And I think, and you look at both of these drones and robots, it's like anything else we see at ARC. It's really the challenge of a lot of companies trying to have, if they don't have the internal domain expertise or, they need technology partners to help them. And that may be, setting up, integrating the robot and drones into their maintenance systems or whatever the case may be, getting all that data, integrated properly. It could be, some companies are out there right now, they're providing, robot as a service, a drone as a service, or drone inspections. They'll take them, usually they'll use a DJI or some other type of drone, and they'll take their pilots and inspectors, and they'll provide a service to certain companies, obviously for a fee. So we're seeing some of that market there. But I think really the last point I want to make is that, as with anything, it's a new technology. So I would say, if you haven't really looked at, your autonomous roadmap, if you will, if you're an oil and gas company or a chemical provider or something like that, you need to sort of look at where you think, if you have autonomous roadmap, where do you see drones and robots coming on? And I always think big, but start small. So I think, try to lay out the applications where you think there could be some real value. Obviously, anything that's dangerous or, routine or robot, there's dirty, what they call it, dirty, dull, and dangerous is the 3 Ds in this space, and you hear that often. So I encourage you to listen to the folks that are going to be presenting here and trying to look at their challenges and any successes they had, and we certainly welcome your questions during the panel discussion. So thank you.
Okay, good morning, everyone. My name is Kamil. I'm a principal engineer in instrumentation and control from Petronas, and I'm here with Shuko, my friend, who's at the back there. He's a principal engineer for process safety in Petronas as well. So today we're going to share some of our applications that we have for drones that we have implemented in Petronas quite recently in the past few years. Okay. So first and foremost, a little bit of information on Petronas. So we are a large integrated oil and gas company. If you can see there, we have our sustainability agenda there, okay, and a lot of our key principles here: value creation, safeguarding the environment, and social impact. Is very we are integrated with what we are doing in all our operations. So we have 4 different business areas. We're doing upstream, of course, for oil and gas extraction. We also do downstream refining, petrochemical plants, oil terminals, gas pipelines, and so on. We have also our gas business, and a new division of new energy. So this is where we venture into things like solar, EV, and hydrogen as well. Right? And we have our division called Project Delivery and Technology, where it provides all the services to our entire operations. Yeah, we operate in over more than 50 countries and about 50,000 strong of workforce from various nationalities. So today we're going to share about 3 use cases on drones. The first one is on methane emissions monitoring. Okay, before we get to the drone itself, some information on methane emissions requirements. So we want to actually reduce the methane emissions as we rely more on natural gas right now as a fuel, right? And Petronas has to step up and actually align our measurements, our quantification with what is in the industry standard. So we have actually established 2 documents. These are internal documents on which is our technical standards here on methane emissions quantification and reporting. And it is accompanied by this handbook, which is actually a guideline to the standard on how we will measure the emissions and perform reduction on this. So these are recently established, 2021. And we have started to embark on our activities to actually measure the methane emissions throughout our operations. So we have a net zero carbon emissions target by 2050, right? And it's a gradual reduction, as you can see from this slide. So we have in 2024, next year, we want to cap our emissions at 49 metric ton of CO2 equivalent, right? And within that number, actually a 50% reduction of methane emissions for our natural gas value chain across our operations, right? Going on to 2030, another 25% reduction of the greenhouse gas emissions, 70% methane reduction, and also 50% methane emission reduction for our natural gas value chain, and reaching net zero in 2050. So that's the target, and that's the setting for the application that we are going to see here on the drone. Okay. With that target, we also have a different two strategies, two actions towards reaching net zero. We have to reduce the greenhouse gas emissions, and this is through operational emissions reductions. Right? So we are looking into how to reduce our flaring, electrification of our energy generation, energy efficiency, and also carbon capture and storage. So these are all going, a lot of activities in this area to reduce our emissions. And we're also looking at business growth in cleaner and green energy solutions. So we have a separate entity that's looking at this, looking at hydrogen, supply of hydrogen, and generating green hydrogen, renewables, and also mobility, as well as biofuels. So this is all in line with our target to reach net zero by 2050. So in order to measure the emissions, we need to have a guideline on what we need to do. So the quantification approach that we have, this is written in our standards, and this is actually taken and aligned with the what you see here, the oil and gas methane framework. So the OGMP, the oil and gas methane framework, is a coalition of over 80 companies and institutions, which set up a guideline on how are we going to achieve methane reduction, how are we going to measure and quantify and achieve reduction. So Petronas is one of the members of that alliance. So what we do here, we actually quantify the different levels of measurement, right? So level 1, 2, and 3 is basically by estimation, by calculations. Right, so it's basically a qualitative calculations. Level 4 is site measurements, where we actually do site measurements of the methane emissions at the ground, and also using remote sensing through drones, so that we can actually get the actual measurements. And level 5 is actually is a combination of level 4 and level 5, which we do source level, which is level 4 at the ground itself, and also site level, meaning site-wide measurement of the emissions. So if you look at the level 4 and level 5, what are the technologies that we are using to measure these emissions? So level 4 is basically the typical technology that we have, IR camera and portable FID detectors. Right? So these are already there in the plant, but we have not actually put them we are using them for other purposes, but not at the emission leak points at the moment, right? So that's the next step that we need to do, and that's level 4. That's pretty easy, pretty basic. So if you go to level 5, so these are where the more advanced technology that we need. For example, this QOGI, hyperspectral camera, right? So this can be fixed or even portable or even mounted on the drone to look at the emissions, right? We also can use this methane sensor using LiDAR or TDLS, okay, time domain laser spectrometry technology. So this can be used to actually measure the methane as well. And also, lastly, satellite imaging, right? All this will provide site-wide methane emissions identification. Right? So the application that we see here for the drone is actually using the LiDAR sensor, and this is to measure the methane. So we have looked at 3 different areas of our operations. to see whether we can actually detect emissions on the sites. So we have the pipeline facilities, which is mainly pipelines with some some interfacing facilities, and then we have the refinery, which represents the downstream facilities, and we also tried that out on an offshore platform on our offshore facilities. Okay, so these are the 3 facilities that we have looked at, and if you see on the findings, this is for the gas pipeline facilities. So you can see that the drone can actually detect there's emission here and at this point. And if you look at the ground, it is actually true. These 2 are venting points of the gas pipelines, right? So the results are consistent. The readings are consistent, but the wind speed is a factor during measurements. Right? So you have a lot of wind, then the reading will not be as accurate, and you need to input the wind measurement, the wind value into the algorithm, so that it can detect properly. Right? And if we map the drone's output reading of images onto the layout of the site, then you can see that the area where it says there are emissions. So you can actually look at this and actually see the actual point of emissions. So it is measuring and identifying it correctly, but the accuracy will need to be improved, of course. So that's for the gas pipeline facilities or onshore facilities. If we look at the offshore facilities, we are scanning this. This is an offshore platform. When we scan it, it is unable to pinpoint the source. It's only able to roughly estimate the area. Okay, so the main reason of this is actually you have the water here. The water actually absorbs the energy, so your reading is affected quite great, very much, right? So, but it is able to show some emissions here as well. And when we go to the sites, then you can see that there is these are points of emissions, the gas chromatography venting, and also the heat exchanger. So it can detect, but quantification is a bit difficult because of the area there. The water is interfering, and also the wind. It's more windy out in the offshore, so that certainly affects the reading. Okay, so that's the application that we have for methane. Okay, the second application or use case is actually using drones for visual fencing and encroachment detection. So we have gas pipelines running all over Malaysia. So those pipelines have what you call right-of-ways, paths where you cannot actually enter without permission, right? So there are a lot of cases where people entering and basically digging here and there, trying to steal some infrastructure there, right? So, and because it's very remote, so it's very difficult. So the idea is to use a drone to actually enforce this, right? So an example of this, for example, this is the pipeline right away. So you have the pipeline here, and you have sometimes you have this what do you call it, stations for all the instrumentation, SCADA system. You also have a fiber optic that runs along the pipeline, right? So this fiber optic is used for data transmission, and it's also used to detect vibration on the areas surrounding the pipeline. Right, so fiber optic can be used to detect vibrations. Vibrations or pressure actually change the waveform of the light, and if you put a detector at the end, you can actually detect this variance and actually pinpoint the location where these changes happen. So we use that to actually detect the area of the intrusion. So, for example, you have unauthorized digging here, right? And then the system will detect it, and will send the location to the drone. So the drone is actually located on top of this building. I'm not sure this would be what, like you said, drone in a box kind of thing. Yeah, it has its own box there. It charges itself there. So the system sends the information to the drone automatically flies up and actually go to the actual location of intrusion, and it will send out an alarm. This is a prohibited area, you are not allowed here, and things like that. So that's the idea to actually scare off the intruder. And it will fly back to its nest once it's done. Yeah. So that's we have implemented, I think, 3 of this in a pilot. So far it's working good. Can you play the? Okay, anyway, but this is just an example of the detection system from the fiber optic. So if you can see there's an intrusion, you see a large variance here, okay, a high reading here. So, and this one will actually show you even the type of activities there from this spectrum. Here you can see digging, and here is something else, I can't see it. Vehicle, yeah, so if vehicle is running along that, you can even see it. Right? So this is actually a video of the drone actually moving out. Can you play it? Okay, you see here the drone is actually flying out from its nest here. So the intrusion is somewhere down here, so it's moving. Okay, so now it's moving down here along this path. So the path is set by the system directly to the coordinates where the intrusion is happening. So the drone is flying between the 2 lines, so it's guided by the boundary of the pipeline. It cannot fly over that. So you can see here the guide is actually doing something, right? And yeah, he panics and runs away because the drone actually, you can't hear it here, but it's actually sending a very large alarm to the guy. So. And then the drone will fly back to its nest automatically. So these are all done automatic. There are cases where the operator can actually take over if there's some issues. That's the box, that's the, what they call the shelf that is open. So the drone will land there. So now it's trying to land, then it's landed, right? And the box will close and the drone will recharge itself. So that's an example of the intrusion detection, intrusion enforcement that we have for the drone. Okay, so I think I'll pass over to my colleague Shuko for this 3rd use case.
Good morning. My name is Shukur. Thank you, my friends, my colleagues. So I will continue on the use case number 3. All right. So we already did use the drone in the process areas. So we conduct some surveillance, some inspection. So for the inspection, we use the hazardous on the flat tips. We inspect the flat tips. We use in the confined space when we empty out all our hazardous material. And then we are also used in the elevated area, especially on the pipe rack. And then in some cases, we use this at the offshore platform where we inspect on the vent area, the vent headers. And we also, like my colleague said, we're using the visual and thermal inspection. And in some cases, but at this moment, it's not yet advanced for the gas leak detection because we need to specify our unit with what type of hazardous material that we are going to detect. Example, like methane, there's special sensor for methane or hydrogen and whatsoever. For the surveillance, we use to conduct the inspection security during the turnaround, during a construction, where we make sure our staff, our contractors, especially using the harness, connect the harness to the safe position so that they cannot fall down to the ground. And then we used to, for the environment surveillance on our facilities. And then we use the drone also for the emergency incident response. This is the insight that I will talk to you later, how we use the drone first in order to prevent exposure of our personnel when we have some incidents, okay? So like the use case number 2 that my colleague mentioned about the pipeline right of way just now. Okay, before I move forward, so maybe some of you not familiar what is the hazardous area means for the process facility. So hazardous area is defined a 3D area in which flammable atmosphere may be expected to be present in the normal operation. So this is when you see the, what you call, some colors, it means that that area is potentially have some presence of hydrocarbons. So this is where that we need to have a drone that non-explosion proof, okay? So at this moment, our unit that we have in Petronas is non-explosion proof, right? So this is for the platforms. Just imagine the platform, the whole platform area is a hazardous area. So we need to send our unit that is explosion proof because we want to prevent this, our drone is become our ignition source. We have so many cases already in our facility that we have ignition source come from the non-explosion proof equipment, especially our lightings, our switches. So we try to improve our facility as well, okay? So this is the elevated view. We have a cellar deck up to the main deck. All the platform is hazardous areas. Okay. So what insights? Performing the in-situ inspection in the reservoir without shutting down the facility is crucial to meet our stakeholder demand. So if you have a unit is non-explosion proof or ATEX certified or EX certified, so we have to shut down our facilities. Otherwise, it will be dangerous to our people, dangerous to our asset and our reputation as well. Drone application is essential to minimize personal exposure to flammable release with a mixture of the toxic material. This is very dangerous when, example, like in upstream facility, we have H2S. Yes, it's dangerous substance. In current, our new business, we have a carbon capture facilities. We have CO2. Okay. In petrochemical plants, we have ammonia. Ammonia also very, very toxic material. So that the equipment, the drone must be ATEX certified or EX certified. So with the drone is not EX certified or ATEX certified, which limit the area and depth of inspection. That's the first thing that we're facing right now. And drone also should be EX or certified. We want also this unit can enter into our combustible area. We have a facility that produce powder. These things are combustible area, combustible material. It can explode also. That in the state we already have some incident with the sugar refining facilities because of this dust combustible area. Okay. All right, I pass back to my colleagues.
Okay, so wrapping up, this is the last slide. So our challenges here is particularly in oil and gas. Applications are expanding for drones. So we're doing surveillance monitoring, encroachment prevention, emissions monitoring, And we have been thinking also using drones to actually deliver supplies to offshore platforms. But that's not materialized yet, of course, for obvious reasons. And also, the design needs to meet these requirements. So right now, of course, you mentioned limitation on payload, limitation on battery power, and things like that. Right? And also, the management of drone services is very important for efficient and reliable operations. In Petronas, we have a Petronas Drone Center. So this group of people actually manage all the Petronas requirements for drone services. So we deal with the regulatory authorities, we get the permits, and we ensure safety of the operation of the drones, so that it's liaised through one body from Petronas. So that's what we're trying to achieve here. So I think we hope that the drones can improve and we can further utilize them in more applications. We also do have robots in Petronas. We have the four-legged robot that's already EX certified, I believe. Yeah. And the animal, the name, and so we use it on one of our platforms to actually go around and check the operations of the facilities. And we also have another robot which is actually I don't know what it's called. It has wheels, but it's magnetic. So it sticks to the pipeline. Yeah. So you can inspect the outer shell of a pipeline in various angles. It sticks there. So that's also another application that we are exploring. So that's a pretty exciting area. I hope we can use it for more applications. Okay, so that's it. Thank you very much.
Morning. Sometimes, do you ever just laugh internally? But I decided I was going to share this, okay? So the only piece of scrap paper that I actually had just to write a couple of notes down was a warning speeding ticket. So that can be your laugh for today. But thank you so much, Tim, for inviting me, and I'm assuming it's the right. We'll just practice. Yeah, there we go. Okay. My name is Gretchen Johnson, and I serve as the CEO of Da Vinci Sky Group. We have several subsidiaries and from drones and helicopters and all kinds of technology with SERDI cameras that look like little Google cars. And we do about anything on the grid. We run around with cameras, and that's just part of our daily life. So Tim invited me to talk a little bit about the drones, and I could be your salesperson when I retire on that deterrent drone. On SIP protocol stations, that could be my gig. So we'll talk about that. And I've got an idea too. So, but this is our company group. If anybody, you can find us under Da Vinci Sky Group. And I'm going to talk a little bit more about automation, software. And it really doesn't matter what industry you're in. Distribution lines, transmission lines, substations, underground, all of that is in my area. But whether or not you're on a gas pipeline, a lot of the automation that you see behind the drones, it's all very similar. And most of the time, those are configurable and they will meet your needs. So if you ever have any I don't just talk about the electric grid. I'm pretty well versed in pipeline and any other thing that you'd like to discuss, anything that can make my mind think above and beyond. 5 years ago, I was saying there's going to be a drone in a box. There is, and everybody's like, oh, we'll never get there. Well, guess what? We just saw a drone in a box, right? And we're going to see more and more of those applications, whether it's for security, whether it's for the grid, whether it's for the pipeline. We're going to start seeing those, and I think I've never. It's funny sometimes when you're sitting into an audience and you start hearing people talk, and they talk about the drones, that it's really hard with the FAA, and I've never had that problem, and probably so is because I started off in helicopters, right? So when we call up, they know who we are, and they're probably more suited to grant us a drone clearance than a helicopter. They're like, hey, that's just only 9 inches, right? So Anyway, we're going to kind of go through a couple of things, and I thought just to start us off with some fun facts other than my speeding warning. Here's a few ways drones are coming into play. Cows with fevers, but you got to make sure somebody's out there with the cow because you got to get the right cow, right? So, but there's actually automation in that the guy actually gets the cow and he brings that cow back onto the stall. I'm not a good farmer. Chasing criminals to get an ID. Now you can go low in the security. Used to, they would say you still had to remain above 50, 60 feet for ID. Now they allow them, if you are 2 inches above their head to get an ID, you can do it. Drones that clean a window. That is something to look up and something to watch in your skyscraper cities. We've seen those people hanging. We actually have men that hang from a rope, and we put them on a pole with a helicopter. Well, those guys would actually, they were hanging from the tops of skyscrapers, 200 feet higher than what we were. Most of the time we're, 100, 200 feet. Drones delivering internet access. You see this a lot in remote places. Up in Alaska, I was a principal engineer on really improving the environment. And one of the things, Scott Trilliant was involved. We had energy hub meters. In Alaska, especially in the smaller villages, it's really not kind of what car you drive. It's more about what kind of refrigerator you have, because they are still very agrarian. So when we're looking at those, the drones were the very first that we were using. Probably, I was in my 40s back then, so 10 years ago, and we were using drones to actually provide the internet service so we could test the sky clearance, right? So even 10 years ago, we were doing some of that. Walt Disney light shows, right down the road. And then America's Got Talent. They use it to do the lights for different folks. So I just thought that was fun. In the utility world, so let's get down to brass tacks. And like I said, whether you're in the gas pipeline, automation, robotics, whatever industry you're in, all of this, they are kissing cousins. So just because I want you to think about your industry and, do some deduction and connection and see how this fits in what you're doing. So drone technology and applications in the power industry is growing at a rapid pace. We know that. We see it coming. Some more standardization with the FAA is really needed. And we've got to get some comfort level. And there's going to have to be some very well understood advocates that can basically lobby the FAA to come on out and get us comfortable with drones. So high definition imagery, LiDAR, photogrammetry. Photogrammetry is totally underrated within my sector, which is the grid. You feel my pain. I go into electric utilities, and I've got this one guy, and I go see him every year, and he is adamant that he is going to use LiDAR instead of photogrammetry. And I'm like, why would you do that when we can run that for $100 a mile versus $600 a mile? And, because really you're just looking for a medium, right? And the drone does a very good job of giving you that medium. We're not looking for mantle photography. We're looking for enough to make a very evaluated situation on how we're going to repair a pipeline, a power line, a generation station, whatever we're repairing. We just need enough information to make the repair, right? Tower inspection, storm assessment, and corona applications, ultraviolet. Nobody really uses those correctly, so I just put both, okay? So that way we're all clear, we know what we're talking about. Storm assessment, let me just kind of plug this. I would like to see, a lot of times we go into storm-ridden areas, and I've served as the principal engineer on 2 storms. One was Sandy and one was Puerto Rico. Both very, very different dynamics. Silt was a big performer of one, and then just underlying vegetation to where it was an Easter egg hunt, just trying to find a power line to get it up. And a lot of the storm, what happens is we go in after the power first to get power back up. But in Hurricane Sandy and Rita and those that was called for. It was a necessity. It was very much needed. But in Puerto Rico, we had to be airborne no matter what you did. Either you had to have a drone, or you had to have a helicopter, or a small fixed wing. And whatever we were capturing at that time, just enough data, because there had been so much erosion that the roads were unclearable. So I would like to see a little bit more around FEMA, the storm assessment area. I would like to see some fencing in of certain standards before we just go headfirst into the power sector. And there are places where we just can't go, right? We just cannot go to Land Bureau restricted areas. You guys, I tell this story when I was so excited. This was like, I was in sales before I owned a company, and I went in and I got this huge thing with El Paso, and I was so excited, and it was my first real inspection with helicopters, a little bit of drone activity. We were having IR, we were doing some corona, we were doing some high definition imagery, and it was just kind of the bomb, right? Well, I didn't realize that I had 7 entities that I needed to communicate with, one of which was Ted Turner's Buffalo Ranch, and then I had a missile place that I got in trouble with, and so despite my sales, I did not realize that they were that strict. I just thought, I'm out here, I'm doing you a favor, Oh, no. So I learned real quick, compliance is everything, right? Compliance translates into getting paid. So I learned that, and then I was off to the races. Indian burial grounds and other protected areas out in SoCal, Edison. The valley wasn't deep enough to bring a fixed wing plane in to get the vegetation scale, to get we needed all kinds of measurements on this power line that was back from 1930. So we were working around all these perimeters, and drones had just really came onto the market. And sure enough, we were able to go to their PUC, and we were able to get some clearance to go in and take a look, and we were allowed only so many steps, and we had to walk on the outside. So there are places where drones cannot be without permission from a PUC. And Indian burial grounds, that is one of them. State parks create their own governing, and a lot of people don't know this. So in Yellowstone, sometimes you're allowed, sometimes you're not. Carlsbad Cavern, you're never allowed, right? So each one of them do their own guidelines, and each one of them, they come up with their own governing around drones, helicopters, fixed wing, anything that's going to be capturing or automating data. Camp David, we kind of understand that, right? We get it. Minnesota and Missouri, restricted areas. So this is kind of interesting that we have 2 states that they do not allow any drone activity over neighborhoods for people that might be sunbathing by their pool. I have a real funny story. We hired Georgia Tech graduates, and they were in our data processing. They were software engineers, and so we would let them come in, and they were all over there just snickering, and I walked over there, and they were all like trying to click everything off, and sure enough, we had some nudists around that the drone had actually captured at 60 feet. So that might be, I don't know if it was from that state, but possibly. And the Bush Ranch, and then Pantex Nuclear Assembly, and 12 other areas. So with this, there comes a high level of compliance, and especially when you're within airports, whether it be an FBO or whether it be an international or a Class B airport, okay? And you're all going to be able to work within zones on how low you can go, right? Kind of like that song, you know? So that we always need to be mindful, and we also need to look at the surroundings before we enter an area with a drone, and especially when it's going to have software animation behind it. So line tower and routine tower inspections, one of the routine parts of a utility is site inspection. You know, one of the things that we need to realize is 5.5 million lines of distro and over 200,000 miles of high voltage, okay? So that's 230 kV and above. They've kind of brought it down. It used to be 345. Now it goes to about 230. A lot of the 230 lines that are operating as 230 lines actually are built as 345 lines so that they do not have to go back and rebuild again. So that's very common in the industry, in the energy industry right now. So even though it's running as a 230, it's probably the capabilities, especially if it's been built in the past, say 5 or 6 years, it's probably built to 345, and if it's 345, it's probably built to 500 specs. If it's 500, it's built to 700 specs. So that kind of tells us. So when we think about 5.5 million miles, and we think about the demographics that you live in, okay? And everybody knows that the distro lines are the little bitty lines that we see kind of flanking our side streets, and probably some of them now, especially if you have a very active EMC or you are near to a independently IOU, that's going to be your big boys, you know. Those now, a lot of times they're trying to consolidate poles so that there's not so much pole pollution that we see. So with that being said, drones are an excellent way because we're not going to be bringing in helicopters. We really don't want to do foot patrols anymore. That's kind of out, other than on substations. And then, too, we've got to be able to capture that data because the U.S. government, basically between NERC and FERC, are saying, we want to know the condition of your lines. So with regulatory, with the state and the feds both wanting that kind of information, the drone is a perfect opportunity to be able to capture that data, push it into a database, and then with that database, you should be able to disseminate it and have visibility throughout whatever you're looking at, whether it be gas, oil, the distro, or the T-line, okay? And even substations. You know, helicopters, a lot of times utilities will kind of we'll get on to site with a helicopter and they'll go, can you just run around the substation with your IR gimbal? And it's like, no, substations and helicopters equal bacon. And we're not going to do that, right? And that goes for pipelines too. So those of you that are in pipelines, even with a helicopter, you talk about a maintenance program that really needs to be intact is a helicopter that's flying down a pipeline, okay? Don't get me wrong, transmission lines are important too, but, helicopters flying low with an apogee or an ALMA system, because that's really what you need to get to. You need to get to a miniature apogee or ALMA system so you can run it in snow or you can still do the detection. And so when we're talking about those systems and we want to make them smaller, we want to make them lighter, we want to make the infrastructure so that if it did collide with something, that it has a transmissional dissemination, right? And that's what we've got to get to. And, that is really when we increase the sustainability, if there is ever an action that is a crash, whether it be helicopter, drone, fixed wing, whatever it is, that it's very minimal, right? And that we're getting the people out of the way first, right? Always first. And I loved in another session, it had a circle and it said the economics are driving it, not the people, right? And so we've got to get to the point to where when we're looking at these solutions that we're making them where they can dismantle themselves before they actually hit the ground. That's where we need to be eventually. So here's some sample data sets. I always like to have everything geotagged, comprehensive visual inspections. A lot of times that's just high definition. There's plenty of plug-and-play drones out there. I've got a couple of favorites, and I never tell that on a platform, because you never know, somebody else may have something better and I just don't know it yet, right? So, but infrared, corona, geotagged HD imagery. I also like the DVR. So when I'm looking at a drone, I'm really looking at the capability for it to do about 4 to 5 different functions at one time. And again, this is applicable substations, power generations, tower erections, QCC. Those of you that are building pipelines, those of you that are building roofing, those of you that may work in a heavy machinery. One of my favorite things, my husband was now I can't tell this yet, but my husband used to fly for Drummond Coal, and he would go back and forth to Columbia. And when his boss learned that we had drones, he was like, hey, can you fly that drone down into the mine and, give us a good idea of what's down there and, where you see the hot spots on the belting? And I thought, yes, that's totally different for us to look at. And so we were able to do that. And so, like I said, just because we're talking about power lines, and that's kind of, what I know, that doesn't necessarily mean that it's not applicable to what you are using things for today. Again, software is configurable. Esri, I have never seen a place where Esri cannot go over and it is usable. I love drone to map. I even use drone to map in a helicopter arena. They would probably die if I said that. So, can you clip that out? But I really like to use that in the helicopter arena because I am able to create data sets, and I'm just totally amused that nobody has done that in that arena and called it helicopter to map. I don't know. But here you can see that high definition imagery, these are so close, the pixels will actually, they'll go to about 27. Then we also can just do up close and personal, when we're looking at different components, and then also just in the generation plants. So I always use a remote geodigital, and if you end up inquiring on remote geodigital, it's Jeff Dawkey. He's out of Colorado. I am one of his biggest fans, and I use that for almost anything and everything that we do on the grid. And just right now, it's a plug and play. It's easy. It's the end users, the ease for, if you're pushing it to a pipeline company, if you're pushing it to an energy company or a ground contractor for QCC, it's just got an ease about it that is extremely user-friendly on both ends. It's not this technical, having to click through, figuring out where to drag it, and then, making sure that it hits the share drive in a certain, it can transpose back and forth with different kind of readers. It's just very easy to use. Here's a sample of some LiDAR mapping. My head shaker right here, when I was talking about photogrammetry and LiDAR, you're usually talking by the time that you build your assumptions and whether or not you're mapping a pipeline, whether you're mapping that power grid for clearances, SAG, whatever you're looking for. You may be looking at a road, you may have several stakeholders, and this is the difference between photogrammetry and LiDAR on a drone, okay? The number one difference is if it is a construction project that has many stakeholders, you are going to want to run that drone with LiDAR, right? Because we're going to get down into sub-meter accuracy. Because let's say that we're going to take a 4-lane road and we're going to expand it to 8. And we got a Chevron station right here, we got a dry cleaners right here, we've got some pad mounts over here, and then over here we've got a natural gas pipeline at the city gate, right? So we've got something on each corners. So once you get over 2 stakeholders, no matter what you do, you're going to run LiDAR. Right? That keeps everybody clean and it keeps everybody informed, and then that will make the project run so much better. Photogrammetry is a little different. It's just going to give you a median, right? And it's not going to be able to give you sub-meter measurements. So when you get into construction projects with various stakeholders, you're always going to use a LiDAR measurement with a sub-meter, okay? Here, survey grade LiDAR, 0.5, orthoimagery, mosaics. The drone does an exceptional job with mosaics. We can get low and you are able to definitely define what you're looking at. One time, I had just gotten into LiDAR and I'd hired this, he was pretty new, he was out of college, and I was very impressed with, what he had been a part of, and I got to looking, and I was like, I don't think that's a power line. I think that's a river. I was like, I'm pretty sure it's a river. And so when you're making your assumptions, just make sure you've got somebody making those assumptions that are the right assumptions, okay? Because we don't need a power line named a river, right? So. All right, and then here's just a set of samples. I think imagery, a lot of times, it can just speak volumes with what we can see and what we're able to fix. Here's another data set. One of the things that we ended up, you end up with sometimes you end up in places you never thought you'd go. Well, this is one of them. And we ended up doing the LNG tanks. And quite frankly, I just never knew that there was a need to measure that vapor barrier with LNG tanks. So this is up at BG&E, and you can definitely tell where there's leaks. We can, there was just all different types of things we were able to see with that vapor barrier. Uses in storms, I've kind of covered that a little bit, with natural disaster, storm damage, trees. We have got to get to where the environment is a part of the power grid. And you guys, it took me a long time to kind of get to that. I've been in transmission since I was 30. So, and back then, we had data asset management, but we didn't call it that. It was like, get this stuff organized so we can see what we're dealing with. That's what we called it. That's how long ago that was. And now we call it data asset management, but we've got to get to the point to where when we're looking at data and we're actually storing the data that we are getting from all of these different types of drones. I love the deterrent drone. I've got ideas for that. And when we're looking at that, we've somehow got to organize this data. And so because we can't get so inundated with data that you're not using it, and that you're spending 6 and 7 months on organizing it, and then you're using it for 3 minutes to make decisions about a project, right? And basically, too, when you're going to fly that drone, whether it be over a pipeline, whether it be over a roof, whether it be on a power grid or a SIP protocol station, whatever you're using it for, make sure that you're communicating with other departments. Hey, we're going to have a drone out there. What do you need to see? Right? So that you're not repeating work that's already being done and you can get it in one run. Because you're going to pay a minimum, no matter what, for drone services. If they're going to be out there for an hour, you're going to pay a minimum of 3 hours. So you need to make sure that you're talking among your departments. Where we are falling short, all right? And I think these are some of the hang-ups with the FAA. This is why they don't know what to do with us yet, okay? It took a long time for the helicopters to get where we are. And that is why helicopters, even with that footprint, are easier to work with than drones. Number one, we've already got a vetting process. We vet those pilots. We know what they're capable of. We know how many hours they've done wire. We know how many hours they've done human external cargo. We know how many hours they flew just ferrying. We know their height, their weight, their heart condition, right? We know what they're doing. So the vetting process, we have got to come up with a way to vet drone operators. And I think that that would bring a comfort level with the FAA, right? Required insurances. You know, when the helicopter comes on site, they know that we are stacked with insurance. There is no doubt about it. We have insured everybody within 50 miles, right, with what we pay. And they just aren't sure with the drone, and even the insurance companies aren't sure with the drone. The utilities aren't sure how much insurance they need with that drone. So we've got to kind of bring that in and kind of, wrangle the masses so that we can go to the FAA with a plan, right? We've got to get a plan, and we've got to have one that looks comprehensible so that we're talking about all of these. Again, background checks. People that fly helicopters, they're not criminals, right? They've been through a background check. If they are on that utility property, they already know in my contract I have signed on the dotted line that they have had a background check and that they are good to go. We don't have that yet with drone operations. We've got to get there. ISN safety ratings. How many of you are familiar with ISN? Okay. ISN users, Avetta, Ariba, we can go on and on, right? Power Advocate, you name it. They put us through the gamut. We've got to get some platforms that kind of help us with that and bring some credibility to what we're doing. Equipment vetting. What kind of drone are you using? Why are you using that kind of drone? We don't want that. You know, I've always been amused. Somebody was like, I saw on LinkedIn one time they had a gas-powered drone right next to, they were saying how they were inspecting a 500 kV line. Now, if there's any corona activity on a 500 kV line and there's a gas-powered drone, we are in trouble, right? That does not make sense. So I was like, maybe you need to take that down, you know. And so requirements for purchase. What do you purchase with a drone? Share drive requirements. What are you going to do to make sure that when you push that data back to me, what does that look like? And how are you ensuring that because you are filming this part of the grid, what are you doing with that? And where are your backups? Like, we are stationed in Birmingham, Alabama. We use Bluehost. Bluehost goes to one city, then one city goes to the other city, right? So we're all the way backed up to the west, but we're working on the east, right? And then vice versa. Backup requirements. How long are you going to keep this on your database? And then last but not least, data processing. Are you keeping the data that you have gotten off of our pipes, our poles, whatever you're looking at? Have you sent that offshore? Okay? And so those are some of the things that I think if we could actually bring some regulatory around those, we would see the drone business move a little faster in these arenas. And then that's my contact. And then I've got my little notes. I'm going to kind of run down through these. I talked a little bit about the El Paso job. I think that's an important one. North Attleboro in Massachusetts. I meant to tell you, Tim, about that. We did a pilot study there, and we were able to get 438 pole tops. They wanted to know what the condition of the pole top looked like. In our industry, the condition of the pole top actually can create IR, and then you get a little humidity laying on the line, and then it can burst into flames. You know, have you ever seen a transformer blow? A lot of times on the distro line, that's what's causing it. So 438 pole tops in one day. Tethering drones for SIP protocol. I think that is another. I think that could kind of go in line with what these gentlemen were talking about and what that looks like. Apogee Alma systems that we are running on helicopters, I think if we could condense those models, put those on some drones, that would be a great pipeline. Future drone in a box, I'm totally in agreement with that. And then in closing, as far as sustainability, drones will enable us to knock out approximately 14 million truck rolls in 1 year. So just think about that. For every truck roll, now this is coming out of the south, okay? So if it's in the south, double it for the north, and I have no idea what California would charge, okay? But I'm just saying, this is in the south. $6.26 per mile per truck roll. Do the math. So when we're looking at sustainability and how drones can interact and help our environment, that's a great place to start.
I'll open it up to the audience to see if you have a question right there, sir. Go ahead.
Hi, my name's M from ExxonMobil. Thank you for the presentation. It was really informative. I didn't hear much about the data play. I understand about the technology, but are there any standards that you guys are part of in terms of the data for the delivery and then as well as the geotag locations?
Yes, so one of the things as far as the data, I always require a data requirements meeting. And what I do is I go through and I see how in-depth they want their imagery, how crisp their imagery is, because the lower and the more clear that they want and how that is geotagged according to their coordinates. I use a lot of different types of technology such as ForeFlight, spider tracks. All of those are plug-and-play methods, and with those methodologies, what they do is they actually keep the drone stabilized, and also helicopters and fixed wings. All of these applications are cross-referenced. But with the drone, they're plug-and-play. So with the spider tracks, for instance, it lets me know if I'm sitting at my office and I want to see where the drone is located and I want to see how fast it's flying, at what height that's flying. Then it also, we take a KMZ or a shapefile, we upload that into ForeFlight, and then ForeFlight, you can actually just program your drone to run. And then, you know, batteries, Tim, I think you talked about batteries. Batteries are still our biggest issue, but ForeFlight, spider tracks, ArcGIS, Esri, drone to map, and remote geodigital. Between those 6, I can about capture anything and collectively get you good data for you to make decisions on.
For those data types, is there a standard that you guys adhere to or conform to, or is it just right now just based on the consultation? And, you know?
Yeah, so it really depends on what the utility or Exxon, whoever, what you're asking for. And As far as standards go, a lot of them don't even know what's out there and available. So a lot of times I'm kind of like taking people by the hand and walking them down the path and kind of talking, this is this capability, this is this capability. Are we trying to take a pipeline for Exxon, and are we trying to map that first? And a lot of times you have to work backwards for the mapping, because that's the very first backbone of any software system, is getting it very well mapped and making sure that those assets have got points, data points.
Thank you.
Okay. We have a kind of a, I didn't mention it in my presentation, but there's a company that I've come to know that has a, probably the most comprehensive end-to-end solution for drones. And they basically designed it because their parent company is heavily involved in ports and container operations. Oh, go ahead.
Hi. Sorry. My name is Sandra Fabiano with Yokogawa. I wanted to ask the Petronas Group, you mentioned wind being an issue with the drones and capturing the methane. With your animal robot, does that help with that situation? Do you use animal to capture that methane that you can't capture with the drones?
I think the animal's purpose is a bit different. It's more towards looking at the operation side, if anything is wrong, abnormal situations, not towards methane. But we could use the animal, actually put a sensor on it and actually go there. But I think it will be a limitation on mobility, because some of the location of the emission sources are quite high or out of reach of the animal robot.
Out of curiosity, I'm not 100% sure, but maybe any of you can answer it. As far as the wind being so strong, does it affect the drones? Is there something set so that the drones will not fly in certain conditions, or do you have to know that yourself?
That's really a company standard. For us, we do not allow over 15 miles, even if it's gyro stabilized, just because the data capture, it can really mess up the imagery, and you want to make sure the customer is paying, that they're going to get what they pay for.
You got a comment? Or?
Yes, Michael Hoteling from ExxonMobil. I apologize if it's the same question. I may need remedial help in the answer. But I guess the question I'm looking at is not about the drone. The drone is just the means, the end, and the tool to capture the data. Mm-hmm. But in a lot of the imagery and the stuff that you capture, like, from, geolocation or tagging of the assets and where those images were done, and maybe I didn't understand the answer, but I'm really curious of, for a lot of the clients that you work with, is there a growing standard or body by which that geotagging is plug and play with a number of other attributes?
The very first question that we always have to answer is, do we have a shapefile or a KMZ to get us started? And we have to start with that, and sometimes we have to go back and we have to start with the mapping. So once you get it mapped, then all really you have to do is we create the GPS coordinates that basically talks to a satellite, and then that gives us our coordinates along the way.
So is that using like a Google Earth, or is there some other, body where you're getting that geolocation standard?
We basically like to LiDAR first, and that will give us down to that accuracy. And that is just calibration. So basically it floats around up in space, and it's helping us get those geo-references as we're flying down the line to create the map. And basically that becomes what I'm referring to as your shapefile or your KMZ. And then after that, you can start your inspections, because then we're going to have that already referenced, the geo-referenced, and then when we're taking pictures or they're running down the line taking the pictures, we've got a leak here, all we do is just drop a pin, and then boom, it interfaces, pushes it down into the database. Once we land, it automatically uploads to your database, to your share file.
just wanted to do a quick introduction here to something that I came across, a company called Holosky. They had to develop their own end-to-end drone solution for their own operations that their parent company has. So I'd like to ask Matthias if you have any response to that question, or just a quick introduction to your, I think people should know about this solution. We became aware of it in the last 6 months to a year. It's a pretty impressive solution, so.
Thank you very much. Yeah, we have solved a lot of problems you guys have been talking about. We are we are a tech company coming from Germany, so we industrialized the use of drones. So we developed industrial drones, meaning they have been built to standards, and we have also developed a mobile robot management software, which is an industry IoT software platform, which is cyber secured according to 62443. So, and what basically it solved is you are able, with our software, with that internet platform, to control more than 100 drones in parallel around the globe, because they're connected via LTE, so which gives you the chance to have BVLOS flights. You can also control mobile robots or moving AMRs for surveillance, for inspection, whatever you have. And all of that is being tracked and being processed in this IoT platform, and goes into a data lake where you can add the artificial intelligence and stuff like that. And this is where we see the future coming. Let's say the whole process being managed up from insurance, from pilot, and down to the maintenance of the batteries and stuff like that.
Yeah.
All of that being tracked and is then therefore revision proofed when something goes wrong and you need to verify. Yes, I have done everything wrong, everything right, nothing wrong. So. This is, so we should talk, definitely.
Absolutely, yes.
Thank you.
Yeah.
Any questions?
I don't know if we answered your question, or yeah.
It's an area.
Right.
I think the industry needs to work in
Yeah,
that direction.
it's an area where I think there should be more discussion and clarity, right?
Mm-hmm.
Because, you know, the means of capturing the imagery is great. And, you know, if you've heard our discussions around, you know, the industrial multiverse, metaverse, or in digital twin, right? Geotagging location becomes critical, particularly when it is among a number of different software platforms.
Absolutely.
Right, and that is an area where we are, I think, at least our company, we're still trying to form our vision around where is it that we need to be advertising from a consumption. Here are the platforms that I'm going to use to get down to that, you know, that geotagging, right? Because I think in a lot of cases, we spend a lot of money on imagery capture, et cetera.
Inspection,
but the organization of that data without a bunch of what I would say curation becomes a big challenge.
Oh, yeah.
the
Right?
automation and the upload on the share drive.
Yes.
And like I said, I have, for years and years and years, this was like back in the 90s, we were, you know, drones, of course, we didn't have drones, you know. I said yesterday, we just saw those on the Jetsons, right? And we thought maybe one day, right? But back then, we would do like miles, hundreds of thousands of miles with a helicopter with a gimbal onto the bottom of it, you know. And we would send over like piles of hard drives, you know, and then eventually got the thumb. But, you know, there's still a mound of them. And I'm thinking, that person is going to sit there for the next 2 years, and by the time that it gets organized into their database, it's time to run another inspection.
Yep, and I think that's an area where, quite frankly, we need, you know, additional help in terms of building out that ecosystem.
Mm-hmm.
One other comment I do want to mention, back from, you know, drone. I mean, a lot of the facilities, or if I, you know, look at some of the Boston Dynamics works of, you know, being open in terms of controls that sit on, you know, these mobile devices. Mm-hmm. One of the areas that we continue to kind of share with them from a concern is, you know, control of the robot or drone is one thing, mm-hmm. but then when you're talking about streaming data, because some of these, you know, can stream data versus capture, we need to make sure that we've had that cybersecurity discussion, because I have found some areas where, you know, I'm looking at, you know, I won't say dual honed, but I'm looking at cards that basically have communication and multi-protocols.
Yep.
And I'm like, okay, this does not sound the most secure place in terms of protecting someone taking control of that, device, unbeknownst to myself.
So yeah, this is something really important you're mentioning. So maybe I can talk about my experience. So my mother company is the Hamburg Harbor Logistics AG. We are running the third biggest harbor in Europe. So we are official critical infrastructure of Germany. So if we are not working, we don't even have bananas available in our supermarkets. So that means we are working 24/7, 360 days a year. Only 4 seamen days are off. And that means we are having higher requirements on safety and on cybersecurity. So, and when I got the order from our CEO, Matthias, make drones available for industrial use in critical infrastructures, and I was sitting there and designing my ideas. So what we have in our drones, there's actually an industrial PC inside. So it works from -15 to up to 85 degrees. We have about eight controllers doing safety, integrated safety, according to 61508. And so that means we have been able to develop the complete platform inside the drone on industrial standards. So, so that means the cybersecurity goes down to the lens, let's say, to the camera, and goes directly back into the back end. So it's everything, the video streaming, the first-person view camera, the capturing of photos, of videos, everything is encrypted. We built even the video streaming ourselves. So we do not use any media server which is available in the market, because why? I was telling my guys, imagine the tank farm in the Hamburg Harbor is burning. The Ministry of Home Affairs will call me up, Matthias, bring your drones up into the air and let's check where we need to evacuate people, where the rescue teams need to enter the fire, kind of thing. And then the video streaming stops. And then what do you guys think? How much time do I have to tell them that I have released a support request to End Server or Vavusa? There's no time. So that's why we built even the media server, everything ourselves, to make sure we have a product available which is working. Because when you think about installing a PCS or DCS system, it's the same with drones. We have an operation center, and if it's there, it will sit there for a couple of years. And that is important to know. So it's a process management tool for mobile robots, for driving, swimming, and flying robots, and all of that is cyber secured. We can actually definitely say, this is your data, this is sitting there, where do you want to have it? Give us in our data lake, and we are calculating these 3D images inside. We're having artificial intelligence developed ourselves for our container cranes. So I'll give you an example of that. This is more than 2,000 tons of steel, a container crane, so it has to be inspected twice a year, and 57 neuralgic points. So what we are doing with the camera, with a high resolution, we're using Sony Alpha 7R, if you guys know that.
Yeah.
So it has 61 million pixels, and we are flying from above, let's say, 20 meters away, and we need to zoom in down to the rust. So we are capturing the photos. The artificial intelligence shows us the growth of rust, scratches in molding, and all this kind of stuff. So, and when we are having more than 60 of these cranes twice a year, that means 120 inspections. And so we are doing the inspection of this crane in 3 hours with our fully automated drone, instead of having 3 climbers or 5 climbers, 1 or up to 2.5 days. So this is where quality, efficiency, and safety is being served by drones.
And another thing too, a comment, one of your competitors, they got themselves really in a bind with cybersecurity because they had hired a drone company that was actually using repeaters and basically it wasn't encrypted, and then all of that pipeline information ended up overseas. It was just, it was a big deal. So anytime that any of you are working with someone that is going to use any repeaters to stream your data, that is a no-no. That's just, yeah, exactly. And then another thing I think that would be important in your industry is that whatever you use and whatever data capture there is for your engineering staff, you want to, in particular, and I'll be glad to have a conversation, but you in particular will want to be able to bring that pipeline into a 3D platform to where a PLS CAD, that they would be able to revolve around that exposed circumference. And I think that that would be very important for your engineering staff.
Yeah, it sounds like, Michael, that there's definitely some follow-up, because as ARC, I'd like to try to help reach out to some of the drone folks to try to see if there is anything existing. If not, what can we do to get that initiative started? Because I definitely think you're hitting a nail on the head. That's.
But I think the ASME community has also been asking the same questions, right? I think as an industry,
Yeah.
I'm not sure we know the answer yet,
Right.
But we do know that in the future, this will be a critical component of
Right.
our overall
Yeah.
transformation, right? And
Right.
the key is, how do we make sure these, we don't have to relive cybersecurity all over
Right.
again? We talk about the data, and I'm glad you're talking about it, because it's critical to where it's not just about the image, getting it to where it can use the image.
And you got to remember that drone is a tool. Helicopters, flying bucket trucks. They're just tools. They're no different than a hammer, a wrench, or whatever, a bucket truck. You know, they're tools. That's right, exactly. But one of the things about the pipeline industry is that if they will pay attention to what has happened on our 500 and 750 lines, that will keep you from making the same mistakes, because they are very interconnected. They are definitely kissing cousins. So the good thing is that most of the mistakes have already been made. So as long as you know someone that is very integrated in that industry, they ought to be able to keep you out of trouble.
Is this an area, again, if I think of across industry, I know the Defense Department and all of the discussions that we're talking has likely plowed some of this ground already.
They have. And then to different states, you're definitely going to have some different state, PSC, PUC embodiment that you're going to need to get through to do certain things. But, you're going to have critical points that need to be mapped. And I just think, when you have the right language in front of them, you can move through that relatively easy.
Thank you.
That's a great topic. I appreciate the back and forth, and I'm glad Matthias was here to give us his perspective, because I really suggest that you check out Hala Sky, HHLA Sky, and this is ARC doesn't plug company, but I was really impressed with what they have, and I think it's especially when you can talk about controlling over 100 drones remotely. That's I haven't seen that by anybody else. Clearly, that's pretty. Of course, they were ex-Siemens guys, so they're over engineering. But anyways, I really want to thank everyone for staying with us here. We went a little bit over here, and I want to thank my great panel of speakers, and I really hope you enjoyed the conference, and there'll be lunch outside, so thanks again.